Physics students, good morning. Mr. Fugit here. So in this video, we're going to be talking about the group problem that you're doing in my absence, which is group problem 4B. This deals with forces on an incline, what we've been talking about in class the last couple of days. So here in the problem, we're not going to work through every part of it. We're going to talk about the setup, how you can get started, what the bonus section is going to be at the end, if you'd like to complete that for a few extra points. So let's read the problem statement together, or feel free to skip this if you're watching the video. I won't be offended. On Saturday, I go downtown for lunch and park my car on a hill. Sometime after I leave my car, my brakes fail and my car starts rolling down the hill. This is at an angle, or the hill is at an angle of 15 degrees above the horizontal, and my car is parked 20 meters up the length of the hill. Assume my axles are well lubricated and my car experiences no friction on the hill. We're not sliding down the hill, our car is rolling, and we'll assume that there's no friction between the axle and the tire, causing it to slow down. How fast is my car going when it reaches the bottom of the hill? My car has a mass of 1,500 kilograms. So we're looking for how fast our car is going. Remember, that's describing a velocity, not an acceleration. Acceleration tells us how much or how quickly we're speeding up or slowing down. So we want to find acceleration first, then use that to find our velocity. So the problem is going to ask you to draw a picture and then eventually use that to put together a free body diagram. So let's just jump right in, go straight to the free body diagram. Here's our hill. We've got a car on this hill. There we go, not bad. And then we are told we're at an angle of 15 degrees above the horizontal straight out, above that, 15 degrees. We're also told that our car is 20 meters up the hill. And that will come into play later. And then we need to put together a free body diagram. So here, there are really only a couple of forces acting on our car. There's gravity, Fg, acting straight down, always, and at least for the scenarios we deal with. And then we have a normal force. And remember, normal just means perpendicular. So normal will be perpendicular to our surface of contact, which is the incline here. So what we've done in the past, or at least the past couple of days, is that we've changed our coordinate system to fit our scenario. And all we're going to do is take the regular system we deal with, x and y, and tilt it to fit our new plane. So what I'm going to do is I'm going to call this down the plane the positive x direction, and going straight up the positive y. And why we do that is to make our direction of motion all one direction. I want to make sure I'm moving just in one direction, not the x and the y. Then it's going to make acceleration and velocity all much more complicated. We just want to set that direction, okay? We want to set the motion in one direction. Okay? So now that we have an idea of our forces and the direction, we're going to use Newton's second law. Okay? So, Newton's second law, sum of forces equals mass times acceleration. So here, I'm mostly going to be concerned with my motion in the x direction. As I roll down the hill, I'm not going to be sinking into the ground or moving off the ground, hopefully. So, sum of forces equals mass times acceleration in the x direction. Now we can also write out our equation for the y. Sum of forces in the y is equal to mass times acceleration in the y direction. Now, as we just mentioned, all of our motion here is going to be in the x. So, I want to find that value, this acceleration in the x direction. The problem is that when we look at our free body diagram, it doesn't look like any of our forces are just in the x direction. So what we have to do is, well, we know the normal force is all in the y. That's not causing any motion in the x direction. We need to take this force of gravity and break it down into its components, what we would call the force of gravity in the y direction and the force of gravity in the x direction. Because it's only that x component of gravity that's going to cause our car to start rolling down the hill once our brakes fail. Okay? You know, force of gravity is equal to mass times our gravitational constant. It's not just g, it's mass times g. you're given the mass in the problem statement, we can find our force of gravity. Now, once we have that, force of gravity doesn't fit in one of our directions. We have to break it into its components. So, we need to find our components using our angle. We've talked about this 15 degrees, this theta, is the same as this angle up at the top. So I can use that and a trig function to find our x and our y components. You'll notice the x component is opposite, so we'll use our sine function. The y component is adjacent, so we'll use our cosine function. So once we find this force of gravity, we're just going to use those trig functions to find our components. And then all we will do is take that force and plug it into our Newton's second law equation in the x direction. Fg in the x is equal to mass times acceleration in the x direction. So we'll know our force of gravity at this point. We'll know our mass. We're just going to use both of those to find acceleration. Okay? Now, we're not going to go through and do all of that for the sake of time, but hopefully that will get you going in the right direction if you feel a little bit stuck. And then once we have acceleration, this problem just becomes a kinematics problem. Okay? We know that we're traveling a distance of 20 meters. We know that we're starting when our car is at rest, so an initial velocity of 0 meters per second. We don't know final velocity, that's what we want, and we will have an acceleration from the previous work that we've done. Time won't be a factor here, so that's all going to tell us we should use equation number 5. Again, we're not going to go through and do that. That's on you. I want you to work through the problem and see what you get. Okay? Don't forget, there's a key up at the front that's also going to help you. Now, in the bonus, what's changing is one thing. We're going to now add in a force of friction. So there will be one more force in our free body diagram. And as you can guess, that force of friction is going to slow our car down. So the new acceleration and new velocity you'll get, if you choose to work this, should be lower. Again, that part is bonus, it's not required. Okay? But this will be very similar to what we dealt with yesterday in the lab. So hopefully this will get you started working through group problem 4B. If you have questions, don't forget to check the key. You can also send anything to me and I'd be happy to try and get back to you as best I can. That being said, good luck. We'll see you all later.